Have you ever wondered what's happening inside a DC machine when it's working? It's a world full of magnetics and electricity, all working in perfect harmony. Today, we're diving into the heart of DC machines. These powerhouses are everywhere, from our homes to industries. They're in your drill machine, powering up your electric car, and even running the fans that keep you cool in the summer. The secret to their widespread usage lies in their simplicity and efficiency. But there's more to these machines than meets the eye. At the core of their operation is a concept known as the armature reaction. It's like the hidden rhythm that keeps the entire system in sync. By understanding the armature reaction, we can unlock the true potential of these machines and optimize their performance. So, are you ready to delve deeper? Understanding the armature reaction will help you comprehend the functioning of DC machines better. So, what exactly is the armature reaction in a DC machine? As we delve into the heart of a direct current or DC machine, we encounter a concept known as the armature reaction. This phenomenon is a fundamental aspect of the operation of these machines, and understanding it can give us a deeper insight into their functioning. Let's break it down. In a DC machine, there are two main components that generate magnetic fields: the armature and the main field. The armature is the rotating part of the machine where electromotive force is generated, and the main field is the stationary part that provides the magnetic field in which the armature rotates. Now, when current flows through the armature, it also generates a magnetic field. This field, known as the armature field, interacts with the main field. This interaction is where the armature reaction comes into play. You see, in an ideal world, these two fields would align perfectly, creating a robust and stable magnetic environment. However, in reality, this isn't the case. The armature field tends to distort and weaken the main field. This distortion is what we refer to as the armature reaction. But why does this happen? The armature field is generated by a current that changes direction as the armature rotates. This changing current shifts the magnetic field, causing it to distort. The distortion then leads to a weakening of the main field, which is the primary source of the magnetic force in the machine. This weakening of the main field due to the armature reaction can have significant effects on the performance of the DC machine. It can lead to a reduction in the generated voltage and can also cause the machine to run less efficiently. So, in essence, armature reaction affects the performance of the DC machine. It's a delicate dance of magnetic fields, and understanding this interaction can help us better design and operate these machines. As we progress, we'll look at the consequences of armature reaction and the ways we can mitigate its effects. Stay tuned as we continue to unravel the mysteries of DC machines. Now that we understand the armature reaction, let's delve into its effects. Armature reaction has significant consequences on the performance of a direct current machine. It can alter the magnetic field, affecting the machine's overall functioning. The two major effects are the demagnetizing effect and cross-magnetizing effect. The demagnetizing effect, as the name suggests, reduces the magnetic field strength. It occurs because the armature flux opposes the main field flux, resulting in a decrease in the net magnetic field. On the other hand, the cross-magnetizing effect shifts the neutral plane. This shift can lead to sparking at the brushes, causing potential damage and reducing the machine's lifespan. Both these effects can have a detrimental impact on the machine's efficiency and reliability. Therefore, it's crucial to be aware of these consequences and take appropriate measures to mitigate them. Remember, these effects of armature reaction need to be minimized for optimal performance. But how can we mitigate the effects of armature reaction? You may ask. Well, there are several measures that we can take to counteract these effects. One such measure is the use of compensating windings. These are additional windings that are placed in slots in the pole face parallel to the armature conductors. These windings carry the same current as the armature, but in the opposite direction. This creates a magnetic field that opposes the armature's magnetic field, effectively canceling out the armature reaction. Another technique is the use of interpoles, also known as commutating poles. These are small poles placed between the main poles, carrying a coil of wire. They produce a magnetic field that aids in the commutation process, helping to reduce the effects of the armature reaction. By using these methods, we can maintain the efficiency of the DC machine, even in the presence of armature reaction. So, by employing these techniques, we can ensure that the DC machine works efficiently despite the armature reaction. Let's sum up what we've learned today. We've delved into the intriguing world of DC machines, focusing on armature reaction. This phenomenon, caused by the magnetic field of the armature current, can affect the performance of our machine. But fear not, our engineering prowess has given us techniques to mitigate these effects, ensuring our DC machines run smoothly. Remember, understanding the armature reaction is key to mastering the operation of DC machines.